Question number 17. In a school, students thought of planting trees in and around the school to reduce air pollution. It was decided that the number of trees that each section of each class will plant will be the same as the class in which they are studying. For example, a section of class 1 will plant 1 tree, a section of class 2 will plant 2 trees, and so on till class 12th. There are 3 sections of each class. How many trees will be planted by the students? It can be observed that the number of trees planted by the student is in AP. That is, first class students will plant 1 tree, second class will plant 2 trees, and third class will plant 3 trees, and up to 12th class. So here first term is 1 and the common difference is 2 minus 1, that is 1. Total number of classes are 12, that is n equals to 12. We need to find the value of the trees planted by the students of each class. So, sum of the trees planted by the students of each class from 1st to 12th equals to n upon 2, n is 12, 12 upon 2 into 2a, a equals to 1 plus n minus 1, that is 12 minus 1 into d, d equals to 1. After solving, we will have as 12 equals to 78. So, it means that total number of trees planted by the students of each class is 78. But it's given that there are 3 sections of each class. So this is the tree, these are the trees planted by the students of each section. Now 78 into 3 equals to 234 trees will be planted by the students. Question number 18. A spiral is made up of successive semicircles with centers alternatively at A and B, starting with center at A of radius 0.5, 1 cm, 1.5 cm, 2 cm, and up to so on, as shown in the figure. What is the total length of such a spiral made up of 13 consecutive semicircles? Now, in short, we need to find the sum of the semi-perimeters of each semicircle. Now here, this is a semicircle with radius 0.5. So now, the length of this semicircle is pi r, because perimeter of a circle is 2 pi r. So semi-perimeter will be pi r. Here radius is 0.5, so L1 equals to pi upon 2 centimeter. Now this is a semicircle with radius 1 centimeter. So length of this semicircle will be L upon 2 equals to pi r2. Here r equals to 1. So length of this semicircle is pi centimeter. Similarly, in the third case, this is a semicircle with center at A and semi-perimeter equals to pi r3. This is a semicircle with radius 1.5. So we have 15 upon 10 pi centimeter. That is 5, 3, 15, 5, 2, 10. 3 pi upon 2 centimeter. Next also, this is a semicircle with center at B and radius equals to 2 centimeter. So 2 pi centimeter is the semi-perimeter of the fourth semicircle. Clearly, the length of each semicircle forms an AP with a common difference of pi by 2. That is, AP is pi by 2, pi, 3 pi upon 2, 2 pi, and continues with A equals to pi upon 2, D equals to pi minus pi by 2, that is pi by 2, 1 minus 1 upon 2 equals to 1 upon 2. We need to find the sum of all these terms up to 13th term. In short, we need to find as 13, n equals to 13, n upon 2 into 2a, a equals to pi upon 2, plus n minus 1, that is 13 minus 1 equals to 12, into d, d equals to pi upon 2. 2 and 2 cancel out. 12 upon 2 equals to 6. 6 pi. Now pi plus 6 pi equals to 7 pi. 13 into 7 equals to 91 upon 2. Pi equals to 22 upon 7. So now 91 upon 7 equals to 13 and 22 upon 2 equals to 11. Now 13 into 11 equals to 143. Therefore, the length of such a spiral made up of 13 such semicircles with center at A and B alternatively is 143 centimeter. Question number 19. 200 logs are stacked in the following manner. 20 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. In how many rows are the 200 logs placed and how many logs are in the top row? Now in this question, logs are stacked in the way such that in the first row we have 20 logs, in the second 19 logs are placed, in the third row we have 18 logs, and so on. So it's clearly visible that the logs are placed in the rows in an AP. In the first one 20, in the second 19, in the third row we have 18, and so on. So here A equals to 20 and D equals to -1. Now the sum of the logs in the first 3 rows are 57. Since it's given that the total number of logs are 200, that is after adding the number of logs in all these rows, sum equals to 200, that is Sn is 200. We need to find the value of n, that is the number of row where last log is placed. So we need to find the value of n such that Sn equals to 200. Since we know that sum of n terms in an AP is n upon 2 into 2a plus n minus 1 into d. Here a equals to 20 and d equals to -1. After solving this equation, we have n square minus 41 plus 400 equals to 0. Now to find the value of n, we need to split the middle term in such a way that after adding the two factors, we will get 41, and after their multiplication, we will have 400. Now from the prime factorization of 400, we have 16 into 25 equals to 400 and 16 plus 25 equals to 41. So we have n square minus 16 and minus 25n plus 400 equals to 0. Now from the first two we have n common, and from the last two 25 is common. Again n minus 16 is common and n minus 25 as it is. It implies that either n minus 16 equals to 0 or n minus 25 equals to 0. That is n equals to 16 or n equals to 25. If n is 16, then a16 equals to 5, and if n equals to 25, then a25 equals to -4. It means that in the 25th row, -4 logs are placed, which are not possible. So we have a16 equals to 5. Therefore, 200 logs can be placed in the 16 rows such that an equals to 5. In the last row, 5 logs are placed. Question number 20. In a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato, and other potatoes are placed 3 meters apart in a straight line. There are 10 potatoes in a line. A competitor starts from the bucket, picks up the nearest potato, runs back with it, drops it in the bucket, runs back to pick up the next potato, runs to the bucket to drop it in it, and she continues in the same way until all the potatoes are in the bucket. What is the total distance the competitor has to run? The competitor starts from the bucket, run towards the first potato, pick up the potato, and then drop it in the bucket. So it covers the distance 5 meters initially, then back again 5 meters. So 5 plus 5 equals to 10 meters. Then a competitor pick up the next potato and covers the distance of 8 meters. Then again run back towards the bucket and drop it in the bucket. So in the whole it covers a distance of 8 plus 8, that is 16 meters. Then for the third time, a competitor covers a distance of 11 meter when he picks up the potato, and then again 11 meter when he drops the potato in the bucket. So 11 plus 11, that is 22 meter for his next turn. We need to find the total distance a competitor has to run to pick up the 10th potato and throw it back to the bucket. That is 10 plus 16 plus 22 up to the 10th potato. Now the distance run by the competitor to pick up the potato and drop it back to the bucket is 10 for the first potato, 16 for the second potato, 22 for the third potato, and so on. So it's clearly visible that it forms an AP with first term 10 and difference 6. That is, we need to find the sum of this distance till the 10th potato, that is S10. Now Sn equals to n upon 2 into 2a plus n minus 1 into d. So S10 equals to 10 upon 2 into 2a plus 10 minus 1 into d. d is 6. Here 10 upon 2 equals to 5. 2 into 10, 20. 9, 6, 54. 54 plus 20 equals to 74, and 74 into 5 is 370. So the total distance that a competitor will run is 370 meter.